Hey there, let's do some trigonometry together. Let's practice finding the exact values of each trigonometric function. For this first example, let's try finding sine of 60 degrees. To find this exact value without a calculator, we're going to need to know a little bit of background information. For starters, we're going to want to know the ratios for the three main trig functions. For sine of an angle measure, it's going to be the opposite over hypotenuse. For cosine of an angle measure, we're going to have the adjacent side over the hypotenuse. And for the tangent of an angle measure, we will have the ratio of the opposite side length over the adjacent. While remembering this acronym of SOHCAHTOA will be super helpful in most cases, let me show you another one as well. You're going to find out that in some cases, taking a trig function of certain angles like 90 degrees, 180 degrees, 270 degrees, and 0 degrees, SOHCAHTOA isn't really going to help us out. In those particular cases, there's another acronym that may be a little bit more useful. So if we take sine of an angle measure, it's going to be the y value over the r value, which is the radius. For cosine of an angle measure, the ratio is going to be the x value over the radius. And the tangent of an angle measure is going to be the vertical distance, or y value, over the horizontal distance, or x value. While it's definitely going to be helpful to remember this first one as SOHCAHTOA, I strongly recommend trying to remember the second one as Seer, Cassier, Tix. I know it's a little weird and I kind of just made it up, but hey, if it works for me, it might also work for you. Not only will Seer, Cassier, Tix work for those angle measures I said of 0 degrees, 90, 180, 270, and 360, it'll work for all the other ones as well. As you dive deeper into trigonometry, you're going to realize that the opposite side length in these trig ratios are really just going to be the y values or the vertical distance in each ratio. In addition, you'll see that the adjacent sides are really just going to be the x values or horizontal distance in each of the ratios. And finally, you'll also find that the hypotenuse of each of them are also really just the radius of each of the unit circles. Since the radius of the unit circle is just equal to 1, this really can simplify it and we can say that sine is really just going to be associated with the y value, cosine is going to be just really associated with the x value since x over 1 is just x, and then tangent is really just the ratio of the rise over run, or the ratio of the vertical distance to the horizontal distance. Now let's draw a sketch and try out this problem. The first thing I recommend doing is drawing a quick xy plane and then just labeling your angle measures that we need for this problem. So where's 60 degrees? Well, 60 degrees is going to be in quadrant 1 and it's going to be located right about here. I'll put a little 60 degrees and I'm just going to draw a vertical line and our reference angle is going to be 60 degrees. Okay. Now, if we know this is a 30, 60, 90 triangle, then the ratio of those side lengths you just want to make sure you remember is 1 to 2 and this one's going to be root 3. Okay, so for all 30, 60, 90 triangles, they're similar to each other and they have these ratio of side lengths, or this ratio of side lengths. Okay, so if we're going to go about doing this, we're going to say sine of 60 degrees, that's this angle measure right over here. That's going to be, well, if you look at it as the opposite over hypotenuse, that's perfectly fine. This is the opposite and this is the hypotenuse. Then we can say that this is going to be equal to the square root of 3 over 2. Okay. Now, if we didn't use SOHCAHTOA and we used Seer, Cassier, Tix, then we would say that sine is going to be the y value, which is also this value right over here. Keep in mind, the square root of 3 is the vertical distance, and the r value is the radius. And so remember that this hypotenuse is really just the radius if you were looking at this on a unit circle. Because we're in quadrant 1 and the y value was positive since we moved up, and the radius is always going to be positive, a positive over a positive means that this value of root 3 over 2 is going to be positive as well. Let's try another one together. Let's try finding cosine of 225 degrees. So we already have a sketch of the xy plane, and for 225 degrees, we're going to have to go outside of quadrant 1, so I'm going to put in our angle measures of 180 and 270. Now, 225 degrees, that's going to be halfway, I think, between 180 and 270. I think that looks just about right. Looks like it's about 45 degrees away from each one. And just keep in mind that we need to draw a reference angle that is, compared to the x-axis there. So we have 45 degrees away from 180. And you can also see, like, if you were to add 180 plus 45, you would get 225 degrees. So we're always looking to use a reference angle. And since we have a 45, 45, 90, and that's one of our special triangles, we know we have a 1-to-1 to root 2 relationship, right? That's just the ratio of the side lengths for a 45, 45, 90. Now, while you can totally SOHCAHTOA, I want you to also think about using our SEER-CASEER-TICS, and since we're using cosine for this problem, we really want to be focused on using this ratio right over here. Sure, you can use the adjacent over hypotenuse ratio, but I think we're going to use the x over r one because it's a little bit more helpful when we think about sines. So what's the x value in this triangle? Well, the x value is really over here. But if we're looking at a coordinate plane, right, anything in quadrant 3 will have a negative x value and a negative y value, right? Everything is negative, negative in quadrant 3. So this isn't really a 1. This is actually a negative 1. And this 1 over here is also a negative 1 because we moved down. The radius, or so I'll say the x value here is negative 1, but the r value, the radius, is the square root of 2. Okay, and the radius is always positive. So if that's a little bit confusing, I'll write this on the side. The radius is always going to be positive. It's a measurement, right? It's just measuring how long the radius is, and that's going to be a positive value. So if we take this and say it's x over r instead of adjacent over hypotenuse, then we can go ahead and say this is going to be negative 1 over the square root of 2. That would be the correct ratio. Now, before you get too excited and just leave the problem at that, just remember that we typically don't like having an irrational denominator, so we can rationalize it by multiplying it by the root 2 over root 2, which is essentially just 1, which is the identity property. And when we do that, we're going to get negative root 2 over 2. All right, so we just have a rational denominator once we do that. Same exact value, just slightly different form, and it's been rationalized here. Here's a third one. Let's find tangent of 330 degrees. So let's see, 330 degrees, well, we know 0 degrees is the same thing as 360 degrees. So 330 should be negative 30 degrees would be another way to think about that. So I'll put 30 degrees away from 360. That'll be in quadrant 4. And I'm just going to draw a vertical line here to show that we have a 30, 60, 90 triangle. Okay, so 330 would be super close to 360. It's over in quadrant 4. And let's see, what are our ratios again? It's 1 on the shortest. It is 2 along the diagonal or the hypotenuse. And the square root of 3 is going to be our x distance or horizontal distance. Now, if we're in quadrant 4, just keep in mind that we have a positive x value, right, if we're talking about coordinates, and we have a negative y value. So that's technically a negative 1. And just to refresh your memory, keep in mind that when we're in quadrant 4, we really have a positive x value and a negative y value. So if we're going to find tangent of 330 degrees, we're looking at this opposite over adjacent, or we can think about this as the ratio of the y value over the x value. And if you're looking at the signs here, we can see that the y value is negative 1, that's the y value, and the x value is going to be over here, that's the square root of 3, that's the x value. So if we find the ratio of y to x, and you can check this is the same thing as opposite over adjacent, but we actually have signs attached to them, then we can say this is going to be negative 1 over the square root of 3. Once again, we're going to have to rationalize this, so hopefully that makes sense, just like the last problem. We're going to have to multiply by root 3 over root 3, and this will be negative square root of 3 over a normal 3, or regular 3. Okay, and so this would be our exact value for this trig function. Now, if you're totally cool with just memorizing your ASTC, or all students take calculus, go ahead and do that, and that helps with the whole SOHCAHTOA part. But if you get used to using SEER-CASEER-TICS, then you really don't have to memorize that either. And hopefully, just knowing about the quadrants and the positive and negative x values and y values, it kind of makes a little bit more sense why certain things are positive or negative depending on what quadrant we're in. As long as you remember that the radius is always positive, and then x and y values are positive or negative depending on what quadrant we're in, then finding the signs of each of your ratios is going to be a little bit more easier, and I think it's going to make more sense. For this fourth example, let's find cotangent of 150 degrees. Now I know this cotangent really isn't one of our sine, cosine, or tangent functions, but just keep in mind that cotangent is really just the reciprocal function of 1 over tangent, right? So if we find out what our value is, we're just going to take the reciprocal of it to find our answer. Don't stress too much about that right now. Let's look at our coordinate plane and decide where 150 is. Well, 150 is going to be closer to 180. It's only 30 degrees away. So that's going to be our reference angle, 30 degrees right there. And if I draw a vertical line straight down, we're going to notice that we have a 30, 60, 90 triangle. And if we have that, then we're in quadrant 2. So that's going to be a 1 over here, and it's going to be a positive 1 because it's moving up. It has a positive y value. And it's going to have a 2 for a radius, and that's always positive. So I'll go ahead and put a positive sign there just to be very clear. And we have, root 3 on the last side, and that is going to be a negative value, right? Anything in quadrant 2, we're going to have a negative x value, but a positive y value. So now that we have that down, if we're going to take cotangent of this trig function, let's really just simplify this and say, okay, let's find tangent of 150 degrees, and then we're just find the reciprocal of that. So tangent of 150, well, if we just find tangent of 30 degrees, we will be just fine, okay? Now tangent is going to be the opposite over adjacent, or we can also think about it as being the ratio of the y value over x value. Either one is okay. And if we take the y value, that's going to be this positive 1, and the x value is going to be this negative square root of 3. So if we're taking tangent, that would be positive 1 over the negative square root of 3. So that's tangent, right? Now if tangent of 150 is 1 over negative root 3, then this cotangent, because it's going to be the reciprocal of it, we can just flip it upside down and say that cotangent of 150 degrees is going to be negative square root of 3 over positive 1, but we don't really need to write over positive 1. So again, don't be too bothered when you have your reciprocal functions. Just use your normal sine, cosine, or tangent, and when you get your solution, just flip it upside down, and that's your reciprocal, and call it a day. For example 5, let's try finding secant of 135 degrees. So once again here we have a reciprocal function of secant, so as long as we know that secant is just the same thing as 1 over cosine, let's just find cosine of 135 degrees, and when we get our ratio we can just reciprocate it or flip it upside down and we'll have our secant of 135 degrees. Okay, so where's 135? Well, here's 90, right? And so if you go to 135, I think that's going to be pretty much right in the middle. And 135, how far away is that from the x-axis or the horizontal axis? Well, that's going to be 45 degrees. Lucky for us, that is a special right triangle once again. And we can find these exact values because we're using these special right triangles. So let's see, our ratio is 1 to 1 to root 2. However, we're in quadrant 2, so we have a negative 1 along the x-axis, but we have a positive 1 moving up and down. And our hypotenuse or radius is going to be the square root of 2. Just keep getting your mind used to the radius and the hypotenuse really are the same thing. And so we have to find cosine of this. And if we find cosine of it, then we can really find what secant is. So cosine is this adjacent over hypotenuse, or it's our x over r value. So let's find cosine of 45 degrees. Cosine of 45, that's our reference angle. And that's going to be the adjacent side over the hypotenuse or the radius, or it's the x value over the r value or radius, and that's going to be negative 1 over the square root of 2. So if that is going to be what cosine of 45 degrees is in quadrant 2 as the reference angle for 135 degrees, then secant of 135 degrees is just going to be the reciprocal. And if we take the reciprocal, that would be root 2 over negative 1, or just negative the square root of 2, or negative root 2. Number 6, let's try finding tangent of 210 degrees. So where's 210 degrees? 210, well, here is 180, so 210 I think is 30 degrees more, and that's going to be over in quadrant 3. So this is going to be a reference angle of 30 degrees. We like that acute angle. And once again, we have our special 30, 60, 90. Now we have a 1, and that's our vertical distance, or our y value. It's going to be a negative 1. And we'll have a radius of 2, and the radius is always positive, and we have a horizontal distance of the square root of 3, and that's going to be a negative x value. Keep in mind that in quadrant 3 we have a negative x and a negative y, so that checks out. Okay, so tangent of 210 degrees, we can really say, let's just find tangent of 30 degrees, and what's tangent of 30? Well, tangent, that's our opposite over hypotenuse, or our tix. So think of TOA or tix, either one is fine. But the same thing is going to be the opposite over the adjacent, or the y value over the x value. And notice how that's going to be negative 1 over negative root 3. So a negative over negative, that's going to cancel out. and that's just going to be 1 over root 3. And to rationalize this denominator, we can multiply this by root 3 over root 3, and our final solution is going to be root 3 over 3. So a little bit of extra work we had to do to rationalize the denominator, but there is our ratio of tangent of 210 degrees is equal to positive root 3 over 3. Whether you use your cosine ticks and keep in mind of your positive and negative x and y values, or you use your ASTC, for in quadrant 3, tangent should be positive in this quadrant as well. Okay, so there you go. Let's try number 7. For number 7, let's find what secant of 270 degrees is. Okay, well, 270 degrees is right down here. So here's kind of the issue where we can't really use SOHCAHTOA, right? We can't draw a triangle because we don't really have an acute angle to deal with. This is on one of the axes. So when this is the case, you want to try to remember what our unit circle would look like. So let me go ahead and draw that for you. If we were to draw the unit circle, keep in mind that the radius of the unit circle is equal to 1. So if we were at 270 degrees, which is right along the negative part of the y-axis, this ordered pair, if the radius is equal to 1, is going to be 0, negative 1, right? That would be the ordered pair at this location. Now, if that's true, the x value is going to be 0 here, and the y value is going to equal negative 1. Now, while we can't do anything with this whole SOHCAHTOA, we can use our cosine ticks, okay? Now, what's secant? Secant is going to be the reciprocal of cosine, so this is 1 over cosine. So in order to find out secant of 270 degrees, let's find out what cosine of 270 degrees is first, and then find the reciprocal of that. So for cosine of 270 degrees, notice how we can't draw a triangle and have our reference angles or anything, right? So we really won't have an adjacent and a hypotenuse for this problem. However, we can use our cosine ticks, or our cosine part, it's kind of funky to say, and that's going to be our x value over the radius. So let's see, what's the x value here? Well, it kind of seems to me like our x value is going to be 0. So we'll put a 0 up here. And what is our r value? Well, the radius is, again, it's 1. So if we have, let's see, 0 over 1, then this is just equal to 0. But if we were to find out what secant of 270 degrees, that would be the reciprocal of 0 over 1, and that would be 1 over 0. Right? And 1 over 0, that is undefined, so we cannot actually find a specific value for that, so that's undefined. Let's try an 8th example together. Let's find what cosecant of 315 degrees is. This is another one of our reciprocal functions, so just keep in mind that cosecant is really just the reciprocal of sine. So if we can find what sine of 315 degrees is, then we can just reciprocate that for cosecant. So where's 315 degrees? And we're going to try to find what sine of 315 is first, and then we can flip that upside down in just a little bit. So 315 degrees, well, let's see. Well, we know, I forgot to, let's just make this back to its original color and just kind of white over it. And let's see, we have 360, that's right over here. So where's 315? I think that's 45 degrees negative of it. So here's negative 45 degrees. And so if we were to draw a reference angle of 45 degrees, it would be in quadrant 4. And what are our x and y values? Well, we have a positive x value and a negative y value in quadrant 4. So we have a 45, 45, 90 triangle, which means we have a positive x, but a negative y, and the radius is always going to be positive. So 1 to 1 to root 2. So there we go. So what's sine of 315 degrees? Well, sine, as we know, is the opposite over hypotenuse, but maybe we'll use the cir from cosine ticks. That's going to be the y value over the r value, or the radius. So we can go ahead and say that's going to be, what, negative 1 over the square root of 2. And if that were the case, we'd have to rationalize the denominator, but don't forget, we have to flip this upside down anyway because we didn't want sine, we wanted cosecant. So if we reciprocate this, then we actually don't have to rationalize at all. Kind of nice. For number 9, let's try finding sine of 240 degrees. So where's 240? We don't have to worry about reciprocal functions for this one, so that's great. So 240, well, I like going to 180 first, and 180 plus 60 is 240. So that's going to be, 240 is closer to 270, so I'm going to go right over here. That's 60 degrees away. That's our reference angle. and drawing a vertical line here, or a y value, we can see we have a 30, 60, 90 triangle, right? And if that's the case, we're in quadrant 3, both x and y are negative. And what's the hypotenuse for things in this, the triangles in this quadrant? That's going to be 2. The radius is always positive. The negative x value, so that's going to be -1 and -√3. Okay, so we're going to have -1, -√3, and +2 in quadrant 3. So if we take sine of 240 degrees, well, sine is opposite over hypotenuse, or SO, or SEER for Seer, Kaseer, Tix. So if we look at that, it should be our y value over the r value. And we can simply just say that this is going to be -√3 over 2. That's it. For number 10, let's try one that looks a little bit more different than the others, and let's go with cosecant of -420 degrees. Now notice how this -420 degrees is a pretty big number, so let's find a coterminal angle to bring it down a little bit. So what we mean by that is just finding, an exact angle measure where we have the same location, but something a little bit easier to deal with. So every 360 degrees is a full revolution in the same location. So if we take -420 and add on 360 degrees, then we can say that that is going to be equal to what? -60 degrees, which is something we can live with. If we add another 360 onto that, we can also say that this location is going to be the same thing as 300 degrees, right? So both of these angles are going to be okay. Now, if you're interested in using the 300 degrees, then that's fine. If you're interested in using the -60 degrees, that's also okay. So where is 300 degrees? Well, if you wanted to think about it, that's moving all the way around, and 300 would be somewhere over here. That's going to be 30 degrees past 270. Or if you also want to start at 0 degrees and just move 60 degrees clockwise, then you'd also end up in the same location. So either one's going to be okay. Just keep in mind that after you draw this, a reference angle is relative to the x-axis, so it's going to be 60 degrees away from the x-axis. Don't use the vertical y-axis. And so here is going to be our triangle that we're going to be considering. Okay. Now, if we're in quadrant 4, we have a positive x value and a negative y value, as everything always is in quadrant 4. And let's see, we're going to have a +1, and we're going to have a -√3 because we're moving down, or negative vertical distance, and we have a hypotenuse of +2. So let's go ahead and just find out what let's see what sine of this 60 degrees is. If we find sine of this 60 degrees for this reference angle, we will be able to reciprocate it for cosecant. So let's see, sine, from 4 we already have is opposite over hypotenuse. And so we're going to stick with that, or we're going to use the y over r. So the y value is this, and our r value is this. So we have what? -√3 over 2. -√3 over 2. Now, that's not really what we're looking for though, right? We really wanted to go back and find what cosecant of this -420 degrees was. So if we flip this upside down, really we can put the negative wherever we want, either top or bottom, but we're gonna have to reciprocate it. And so I'm gonna say this is gonna be -2 over √3. Okay, that's it flipped upside down. Now notice it's a little bit more work. We have to rationalize the denominator, so we're gonna multiply by √3 over √3, or the same thing as 1. And finally, we'll have 2√3 over 3. This is the exact value of cosecant of -420 degrees. Now that we tried 10 examples using degrees, let's switch over to radians and see how we do with those. So for number 11, let's go ahead and see if we can find out what tangent of 7 pi over 6 is. 7 pi over 6. Go ahead and see what that is. And let's go ahead and change out all of our degrees. So I'm going to get rid of this, all these angle measures in degrees, and let's switch them over to radians. So if we're going in radians, we have 0 pi's, and we have a full revolution would be 2 pi. So those are the same thing. If a full revolution, or 360, is 2 pi, then 1 pi is just going to be 180 degrees, and half of that would be 90, so 90 would be half of a pi. And if we go to 270 degrees, that should be 3/2 pi, or 1.5 pi. So same thing, just moving all the way around, but everything is going to be in radians now. Just try to remember the degrees in your head as well. So 7 pi over 6, well, that's definitely an improper fraction, so it's more than one whole. So let's see, we have 1 pi here and 3/2 pi, or 1.5, or 1.5. Now 7/6 is improper, and it's a little bit more than 1, so it's an extra 1/6 of a pi over into quadrant 3. So this angle measure is going to be pi over 6. Now, what do you think pi over 6 is? Well, if pi is 180 degrees, then if you divide that by 6, that's 30 degrees. So this is really just a 30, 60, 90 triangle. Okay? So just try to remember, if you know 180 is the same thing as pi, then pi over 6 is 180 divided by 6. So that's 30 degrees. So if that's 30, then we have a ratio of what? 1 to root 3 to 2, the same special triangle. And if we are in quadrant 3, we know we have a negative x value and a negative y value. So that means this is going to be a negative x and a negative y value. So if we're finding tangent of this angle measure, that's opposite over adjacent, our TOA or our tix. And so that's going to be our y value over our x value. And so what's that going to be? Well, they're both negative, so we can cancel the negatives out, and that's going to be 1 over the square root of 3. Now, we got to rationalize this, so multiply by root 3 over root 3, and we should have a final value or ratio of root 3 over positive 3. There we go. Number 12. Let's find out what cosine of 3 pi over 4 is. Okay, so 3 pi over 4, that's 3/4 or 0.75, so we need 3/4 of a pi. Well, we know we have a full pi over here, and we know we have a half a pi over here, so between a half and a full is 3/4. So let's go with this, and that's going to be 45 degrees in between, right? So this reference angle is going to be pi over 4. We know that's 45 degrees because that's halfway between 180 and 90, so it's going to be really 135 degrees if we think about it. And so this is going to be our reference triangle, a reference angle of 45 degrees. So if we have a 45, 45, 90 triangle, our ratio is going to be 1 to 1 to root 2. And if we're in quadrant 2, that's a negative x value and a positive y value. So let's throw on a negative on the x value and keep the y value positive. The radius is always positive. And if we're doing cosine, well, cosine is this ca, or this cassir. And so let's go ahead and say that's x over r. So adjacent over hypotenuse, or x over r. So cosine of this, that's going to be negative 1 over square root of 2. Now, if we have to rationalize this, multiply by root 2 over root 2, and it should be negative root 2 over 2. There we go. For number 13, let's go ahead and find what cosecant of 5 pi over 3 is. Let's give that a go. So cosecant, that's the reciprocal of sine. So let's just find what sine of the reference angle is and then reciprocate it. Now, where's 5 pi over 3? 5 pi over 3. Well, that's definitely more than 1 whole pi. So here's 1 whole pi. And is it more than 1.5? Well, 5/3 is 1 2/3. That's more than 1.5. So I'm thinking it's going to be somewhere here in quadrant 4. And so it's going to be what? 1/3 away from a full 360 or full 2 pi. So I'm thinking it's going to be right around here. Okay, so let's see. If we had 6/3 pi, 6/3 pi is going to be 2 full pi or 360. So if we know pi is 180, then 1/3 of a pi, or 180 divided by 3, is 60 degrees. So we would have a 60-degree angle here. Oh, let's try to get used to radians a little bit more. I'll put pi over 3 away. So it's 1/3 of a pi away from being 2 whole pies, right? 5 out of 3, and if we had 1 extra third, that would be 6/3 or 2 whole pies. So it's 60 degrees, so it's a 30, 60, 90. The 1 would be here, the root 3 would be the vertical distance, and the 2 is the hypotenuse. If we're in quadrant 4, we have a positive x value and a negative y value. So here's our positive x and our negative y. And the radius is also always positive. Okay, so let's see, we can find sine. Let's find sine of this pi over 3, the reference angle. Again, that's just 60 degrees. Just try to get used to the radians here. And that's going to be so, or seer. And that's going to be the negative root 3 over positive 2. So that's going to be negative root 3 over 2. Again, that's for sine. So for cosecant, we're going to have to find the reciprocal of that, and that's going to be negative 2 over root 3. And unfortunately, now we have to, rationalize. I don't know if it's unfortunate, but it's just more work. So it's going to be negative 2 root 3 over 3. I wrote the wrong number. Cool. There we go. 14. Let's try finding what sine of pi over 6 is. Sine of pi over 6. Okay, well, sine of pi over 6. Pi over 6, well, we know pi is 180 degrees, right? That's one that we definitely want to know. And dividing that by 6, that's going to be 30 degrees. So also, if we're just thinking about that, that's 1/6. That's only a little bit more than 0. So that's going to be pretty acute. Maybe something like right here. That's 30 degrees, so let's put pi over 6. That's our reference angle. It's kind of nice. We don't have to do much work here. And so what do we have? We're in quadrant 1, so everything's going to be positive, positive. So we have 1, that's our shortest side. We have root 3, and we have a 2. We're in quadrant 1, so that's a positive, comma, positive. Radius is positive. Everything here is positive, positive in quadrant 1. And let's see, sine. Oops, I forgot to erase it earlier, but it's still this so and this seer. So what's the y value? The y value is going to be 1, and the r value is 2. So positive 1 over 2. And it's nice. We don't have to reciprocate anything or rationalize anything. That's our final answer. Example 15, let's find out what cotangent of 5 pi over 6 is. 5 pi over 6. Let's give that a go. Cotangent, let's see. Cotangent is a reciprocal function for tangent, so if we find what tangent is going to be, we can reciprocate it. So let's see where 5 pi over 6 is first, though. So that's almost 6 out of 6, or 1 whole. So here's a whole pi. And so we're really a sixth shy. Sorry, it's a 1/6, a little bit less than 1 full pi. So what is 1/6? Well, 1 full pi is 180, so divide by 6. This is really just a 30-degree angle, 30-degree reference angle over in quadrant 2. So there is our 30 degrees, or pi over 6. And so that's going to be 1 to 2 to root 3. And let's think about our signs over here in quadrant 2. That's a negative x and a positive y. So negative x, positive y, positive radius. And let's see, we're talking about tangent. So we can either think about TOA or our ticks, since we already know our signs. Ticks, that's y over x, y over x. So tangent of pi over 6, our reference angle, is going to be equal to positive 1 over negative root 3. All right, that's that value. Now, we didn't want tangent, we really wanted cotangent, so we're going to have to flip that upside down. Thank goodness, because then we don't have to rationalize the denominator. It should just be equal to negative square root of 3. For example 16, let's find out what secant of 11 pi over 6 is equal to. 11 pi over 6. What is it? That's almost 2 whole pies, right? 12 over 6 would be 2 whole pies if we simplify that down. So here's 2 whole pies, same thing as 360 degrees or 0 degrees or 0 pies. And so we're 1/6 shy away from being a full circle or full 360 degrees. So that means we're 30 degrees away. Okay, so this is our pi over 6. You've seen that a bunch of times now. And so here is our reference angle of pi over 6. And we're in quadrant 4, right? So let's see, 30, 60, 90, that's going to be 1. This is root 3, and this is 2. We have a positive x, but we have a negative y and a positive radius. In quadrant 4, we have a positive x and a negative y, just to be consistent. And let's see, secant, that's the reciprocal of what? Cosine, so that's 1 over cosine. So if we can find what cosine is, then we can just reciprocate. So either ca or casir, however you want to say it. And so cosine of pi over 6, cosine of 30 degrees is equal to what? Well, that's going to be the adjacent side, or the x value, over the r value. Right? So x value is positive, so positive root 3. The r value is also positive. That's going to be 2. So we know cosine is root 3 over 2. So secant is going to be the reciprocal, or 2 over root 3. Now to rationalize this, a little bit of extra work, but not too bad, getting used to it. This will be 2 root 3 over 2. And there you have it. For example 17, let's find out what cosine of 7 pi over 4 is equal to. Cosine of 7 pi over 4. Okay, so our fraction of 7/4 is almost 8/4. 8/4 is 2 wholes. 8 divided by 4 is 2. But we're missing a quarter, so if we know a full pi is 180, then divide that by 4, that's going to be 45 degrees. And so we're going to be 45 degrees short of a full circle. And so this is pi over 4, or 45-degree angle. And so this is another special one. And we have a ratio of 1 to the square root of 2. And we are in quadrant 4, which means we have a positive x and a negative y. So here's our positive x, here's our negative y, positive radius always. And so cosine of this is going to be the k, or the kasir. And so we have our x value over our r value. So that's going to be 1 over root 2. And we're going to have to rationalize this, so multiply it by root 2 over root 2, and we'll get a final ratio of the square root of 2 over 2. That's our rationalized version. For example 18, let's go ahead and see what cotangent of negative 8 pi over 3 is equal to. Okay, well, cotangent, that's the reciprocal of tangent, so that's going to be 1 over tangent of whatever the reference angle is going to be. And let's see, we have a pretty big angle here. Maybe it'll be easier if we find a coterminal angle. So let's go ahead and see, negative 8 pi over 3. Let's add on 360 degrees to get it closer to 0. 360 is the same thing as 2 pi. So if we add on 2 pi, let's get common denominators. That's really 6 pi over 3. That's adding on 2 pi, or a full revolution. So same location. This would be equal to negative 2 pi over 3. So same location as the original one. And if you added another 6 pi over 3, if you wanted a positive coterminal angle, this would be 4 pi over 3. So either one you want to use, I think this negative one is going to be just fine. But if you prefer positive angles to deal with, you could also use this 4 pi over 3. Same location. So I can go ahead and show you too where this is going to be regardless. And so if we are at 0 pi's over here, this is half a pi, this is a full pi. And if you're using positive, we're going an extra third of a pi into quadrant 3. And that's if you're going the positive route. And if you were taking this and going the other way, you can see this as, okay, here's 0. And if we go negative 2/3 of a pi, we would go not quite a full pi this way, would be a third short. So either way, we're going to end up here in quadrant 3. Okay, so how far away are we from a regular pi or one full pi? We're going to be 1/3 of a pi away from it. Okay, and so 1/3 over a full pi is 4/3, but we can also go 2/3, negative 2/3 in the other direction. And so here we have our angle. So 180 degrees is pi, so pi over 3 is 60. So we have 1 to root 3 to 2, that's our ratio. We're in quadrant 3, so we have what, a negative and a negative. And so we're definitely going to have a negative x, a negative y. Radius is always positive. So this one's a lot of work. We just have to go through each of these pieces. We're dealing with tangent, right? So if we find out what tangent is, then we can find out what cotangent is. So tangent of pi over 3 in this quadrant actually is going to be, well, with the signs, it's not completely perfect, but I know I'm talking about just the reference. And so tangent is O over A, or y over x. Here's the y, here's the x. That's going to be negative root 3 over negative 1, or just root 3. And if that's what tangent is, then cotangent is going to be the reciprocal. So that's going to be 1 over the square root of 3, because we have to find the reciprocal. And then if we go ahead and rationalize this, then we will get a root 3 over 3, and that will be our final ratio. For example 19, let's go ahead and find out what tangent of negative 3 pi over 4 is equal to. So let's see, 3 pi over 4, that's less than 1 full pi, but we're going in the negative direction. So here is 0 pi's, that's going to be along the positive x-axis. And if we go ahead and take half a pi, that's going to be negative 90 degrees. And if we go another quarter, that will be our negative 3 pi over 4. So that's going to be over in quadrant 2. So if you wanted to use that, that's perfectly fine. But you could also use another coterminal angle. And if you wanted to add on 2 pi, or in this case with common denominators, that's going to be 8 pi over 4, which is the same thing as 360 degrees. Then we could look at this and say this is 5 pi over 4. So if you want to go from another direction, you could go in the positive direction and go from counterclockwise. This is a half a pi, a full pi, and an extra quarter going from the positive direction. That's also okay. Now our reference angle is going to be pi over 4, or the 45 degrees. And that's going to be a 45, 45, 90 triangle. So we have the ratios of 1 to 1 to root 2. And if we're in quadrant 3, we have a negative x value and a negative y value. So we know that this is going to be a -1 and this is going to be a -1, and our radius is always positive. So if you go ahead and take tangent, that's O over A or y over x. And so we're going to say this is going to be the y value over the x value. Now, -1 over -1 is really just going to simplify down to being +1. And for our final example, example 20, let's find out what secant of 11 pi over 6 is equal to. Now, again, secant is a reciprocal function, so that is going to be the reciprocal of cosine. So let's find out what cosine is of the reference angle. And for 11 pi over 6, that's really close to being a full 2 pi. 2 pi would be 12 pi over 6, so if we were to go ahead and show where that would be, I think we would be just slightly shy of a full circle. It would be 1/6 short from it. So we can go ahead and draw a triangle, and pi over 6 will be our reference angle over in quadrant 4. And so pi over 6 is 30 degrees, so we have our 30, 60, 90, and that's going to be 1, √3, and 2. And we know we have a positive x and a negative y in quadrant 4, so that lets us know that this √3 is going to be positive, and this 1 is going to be negative, and our radius of 2, or hypotenuse, is positive as well. And so let's go ahead and find out what cosine of this pi over 6, this reference angle. That's going to be our a over h, or our x over r. Our x value is positive √3, and our r value, or radius, is 2. So we're going to have a positive √3 over a positive 2. Now, that's what cosine of that is equal to, but we need to find secant, so we need to find the reciprocal, and the reciprocal of that is going to be 2 over the square root of 3. Now, one last time, we really need to make sure we rationalize that denominator, so we're going to multiply by √3 over 3, √3 over √3, and that's going to equal 2 √3 over a 3. That would be the exact value for secant of 11 pi over 6. And there you have 20 different examples of finding the exact values of trigonometric functions. The first 10 examples were finding them using degrees, and the second 10 problems were dealing with them in radians. So I hope you found this helpful, and as always, keep up the great work. I'll see you in the next one.